Okay, so this is a paper 1, pure mathematics, from June 2024 at Excel, A-level maths. And in this video, I will go through every single question. I'll show how to work out step by step. And I will also explain the different concepts involved in the questions. So yeah, let's get started. Okay, question 1. G of x is given as 3x cubed minus 20x squared plus k plus 17 times x plus k, where k is a constant. Given that x minus 3 is a factor of g of x, find the value of k. So basically this question is based on factor theorem, and according to factor theorem, if x minus a is a factor of f of x, then f of a is equal to 0. So that's what we can use. So x minus 3 is given as the factor of g of x. So you can say that g of 3 will be 0. Now g of 3 will be, we just substitute x equals 3 here. So 3 times x cubed. So 3 cubed minus 20 times 3 square plus k plus 17 times 3 plus k, and this will be 0. So now we solve this. So 3 cube is 27 times 3 will be 81 minus 20 times 3 square is 9. So 9 times 3 is 18. So 180 plus 3k plus 17 times 3 is 51 plus k equals 0. So if we add the like terms, so 3k plus k is 4k, and 81 plus 51, it's better to use calculator. So 81 plus 51 and then minus 180, that gives me minus 48. So if you put 4k equals 48, then k will be 48 divided by 4, which is 12. Okay, let's verify the answer. So k is 12. So that's correct. Question 2, part A. Find in ascending powers of x the first 4 terms of the binomial expansion of 1 minus 9x to the power half, giving each term in simplest form. Okay, so basically I will give you a little bit of explanation about the binomial expansion. So basically, when you have like negative powers or fractional powers, we have to use a formula. So for example, if this is 1 plus capital X, now X can be anything. In this case here, like if you compare with this one, your X will be minus 9X. Okay, so yeah, so the general formula for negative powers or fractional powers for binomial expansion is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1 n minus 2 over 3 factorial x cubed, and it will carry on. So 2 factorial is basically 2 times 1, 3 factorial is 3 times 2 times 1. Okay, so we want here the first 4 terms in this expansion. Okay, so we want these 4 terms here. So basically 1 minus 9x to the power half. So your x in this case is minus 9x and your n is half. Okay, so when you do the expansion using the above formula here, you can write 1 plus n is half times x is minus 9x. So it's better to write everything in brackets and then later you can simplify. So 1 plus nx plus n is half, and then half minus 1 over 2 factorial. 2 factorial is 2 times 1, which is 2, and then minus 9x whole square. Okay, plus half times half minus 1 times half minus 2 over 3 factorial, which is 3 times 2 is 6, and then minus 9x to the power 3 plus dot dot dot. There will be more terms, but we only need to find the first 4 terms. Okay, now we will, instead of putting everything in the calculator, we will try to do a little bit of simplification here. So 1, and then half times minus 9 will be minus 9 over 2x, and then here half times half minus 1 is minus half. Minus half times half is minus a quarter, and then divide by 2 will be minus 1/8. So this will be minus 1/8 minus 1 by 8, and then times minus 9 square will be 81, and then x square. Okay, and then here will be half minus 1 is minus half. So you have half times minus half, and half minus 2 will be minus 3 by 2, and then minus 9 cube will be 9 times 9 is 81. 81 times 9 will be 729, and that will be minus 729 x cube. So if we divide this by 6, so 3 divided by 3 is 1, 3 times 2 is 6, and then 2 times 2 is 4, times 2 is 8, times 2 is 16, and minus minus becomes plus, and there's a minus sign there, so overall result will be minus 729 over 16 x cubed. Okay, so your final answer will be 1 minus 9 over 2x minus 81 over 8 x square minus 729 over 16 x cubed plus dot dot dot. There will be more terms, but we only need to find out the first 4 terms. Now, one thing I forgot to mention in the beginning, that this expansion here at the top is only valid for a condition. So the condition is modulus x must be less than 1, or you can say x is between minus 1 and 1. So it's the same thing, you write this way or that way. Okay, now in this case your capital X is minus 9x. So I'm talking about like trying to do part B. Give a reason why x equals minus 2 over 9 should not be used in the expansion to find an approximation for square root of 3. I mean, think about if you put x equals minus 2 over 9 here, like 1 minus 9 times minus 2 over 9 to the power half. This becomes 9 divided by 9 is 1, and then minus minus becomes plus, so 1 plus 2 becomes 3. 3 to the power half is basically square root of 3. So square root of 3, we can expand it using this formula, but we cannot use this because if we, let's say, if we apply this condition, so your minus 9x must be between minus 1 and plus 1. Okay, now if we divide everything by minus 9, remember when you multiply by a negative number, you have to reverse the inequality. And the reason for that, like for example, minus 2 is less than 3. If you multiply by a minus sign on both sides, then this becomes plus 2 and this becomes minus 3. And now 2 is bigger than minus 3. So whenever you multiply or divide by a negative number to an inequality, you have to change, reverse the order of the sign of inequality. Okay, so in this case, if we divide by minus 9, so this becomes 1 over 9, and then this becomes x, and this becomes minus 1 over 9. So basically, you can rewrite this is the same thing. You can write this as x must be between minus 1 over 9 less than 1 over 9, or modulus x must be less than 1 over 9. Now, we're using minus 2 over 9, which is less than minus 1 over 9. So that's why we cannot use x equals minus 2 over 9 to find the approximation for square root of 3. Okay, let's check the answer quickly. So 1 minus 9x over 2 minus 81 over 8, 81 over 8x squared minus 729 over 16 x cubed. So all correct. Question 3. f of x equals x plus 10 half x, where x lies in the interval x is greater than pi and less than 3 pi over 2. Given that the equation f of x equals 0 has a single root alpha, show that alpha lies in the interval 3.6 and 3.7. Okay, so to do this question, so they gave us that this function fx equals 0 has a root alpha. Now, if this root lies between, if this is alpha, that's where f of x is equal to 0. Now, to check if whether this in this interval, if alpha lies in this interval, then either this is the case, like f of 3, like you check on either like if this lies between 3.6 and 3.7, so you have to check for the sign change. So either this will be positive or this will be negative, or the other way around, it will be something like this. This is not the exact shape of this graph, but just like a rough graph to understand. So this will be positive and this will be negative. I mean, this is a continuous, assuming that this is a continuous function. So you just have to check for the sign change. So let's calculate the value of f of 3.6 and calculate the value at f of 3.7. So we can use calculator here. One thing you have to be sure that the x is in radians, so we need to make sure to change the mode in your calculator to be radians. So let's check the value of f of 3.6. So x is 3.6, so 3.6, so let me write it down. So 3.6 plus 10 half times 3.6. So 3.6 plus 10, and 3.6 times half will be 1.8. So 10 of 1.8. So this gives us a value of minus 0.686 to 3 decimal places. Now let's check at the value at 3.7. So 3.7 plus 10 half times 3.7. So you do 3.7 plus 10, 3.7 divided by 2. So that gave me a value of 0.212 to 3 decimal places. Now you can see there is a sign change between for the values at 3.6 and the value of the function at 3.7. So this is actually this case. So there is a sign change and it's a continuous function. So that means alpha lies in the interval between 3.6 and 3.7. So that's part A. Now part B is find f dash x. So we need to differentiate this function. So just for reference, differentiation of 10x is sec squared x. Okay, so if we differentiate this, differentiation of x will be 1 plus differentiation of 10 half x. So first you differentiate assuming that half x is capital X, so that becomes sec squared half x, and then use chain rule to further differentiate half x. So when you differentiate half x, that will give you half. So half sec squared. So this will be f dash x. Okay, now question C. Let's go to the next slide. It will make it easier. So using 3.7 as a first approximation for alpha, apply the Newton-Raphson method once to obtain a second approximation for alpha. So give your answer to 3 decimal places. So your x0 is given as 3.7, and apply Newton-Raphson method to obtain a second approximation. So you need to work out x1. Okay, so that will be, if this is your first approximation, then second approximation will be x1. So so just for reference, Newton-Raphson method, Newton-Raphson method. So this is given by xn plus 1 equals xn minus f dash x xn over fxn. Let me quickly double check this because sometimes I get confused and swap the two. Let me quickly check this. Newton-Raphson method. I mean, there will be a formula booklet given to us. So, okay, so this is the other way around. So your fx is at the top and f dash x at the bottom. So this is f dash x. So let's work out the value of, so if you put n equals 0 here, that will give you x1 equals x0 minus f of x0 over f dash x0. Now x1 will be x0 is 3.7 minus f of x0. So x is 3.7 plus 10. We have already calculated this value, actually is 10 half times 3.7. That will be the value of f of x0 divided by now f dash x was, we write 1 plus half sec squared half x. So if we just put x0 as 3.7 here, so 1 plus half sec, you can write it as 1 over cos squared half times x is 3.7. We have to calculate this, the value of this value of x1 using calculator. So instead of putting everything in one go, we can just do simplify the numerator first. So that is 3.7 plus 10 and 3.7 divided by 2. I think we have already calculated this. So that comes out as 0.21223 decimal places. And then, oh, actually, let's keep it 0.2119404. Keep as many decimal places as we can. And the denominator is 1 plus 0.5 times 1 divided by cos 3.7 divided by 2, and then I close the bracket. I put another bracket here, 1 divided by cos square it. That comes out as 1 plus 0.5 times 1 divided by cos square 3.7. Okay, yeah. So this comes out as 7.583279. Now let's work out all together. So 3.7 minus 0.2119404 divided by 7.583279. So this comes out as 3.67205516. To 3 decimal places, it will be 3.672. Let's check the answer. So 3.672. Okay, so that's the answer. Question 4. Given that y is equal to x squared, use differentiation from first principles to show that dy over dx is 2x. Okay, so first principle, so when you differentiate dy over dx, so for example, if y is equal to f of x, and if you have to differentiate this using first principles, so this can be written as limits h tends to 0, f of x plus h minus f of x over h. So basically what we try to do here is, so we expand the numerator, simplify, and at the end we will be able to cancel the h from the denominator, and then we substitute h equals 0, because at the moment we cannot put h equals 0 in the denominator, so that's why we have to simplify the numerator, and then h will be cancelled from the denominator, and then you can substitute h equals 0. So let's see. So your fx in this case is x squared. Your f of x plus h will be x plus h whole square. Now if we do dy over, you can expand this as x squared plus h squared plus 2xh. Okay, now dy over dx using first principle will be limits h tends to 0. Like h tends to 0 means h is very small. Okay, so if we put f of x plus h, which is x squared plus h squared plus 2xh, minus f of x, which is x squared over h. Now this x squared cancel. Make sure you keep writing limits h tends to 0. Now you have h squared plus 2xh over h. Now if we divide each of the term by h on the numerator, then this becomes limits h tends to 0, h plus 2x. Now h is removed from the denominator, so now h is very small, so you can just simply put h 0, so you will get 2x, and that's what you were supposed to prove here. Okay, I can show you the mark scheme quickly. Yeah, same thing. Question 5. The function f is defined by fx equals 2x minus 3 over x squared plus 4, where x belongs to all real numbers. Question A. Show that f dash x is ax squared plus bx plus c over x squared plus 4 whole square, where a, b, and c are constants to be found. And then question B is, hence using algebra, find the values of x for which f is decreasing. You must show each step in your working. Okay, so for this question, looking at this question, it looks like we have to use the quotient rule. So quotient rule, just a quick brief of what quotient rule is. If you have a function y equals fx, or fx is in the form u over v, like a fraction, then dy over dx, which is f dash x, is given by v. U and b are both functions of x here, so v u dash minus u v dash over v square. Okay, so remember v in the denominator, so is squared, and then you start with v. So what you have in the denominator comes in the denominator here as v squared, and you start with v u dash. Okay, now in this question, fx is 2x minus 3 over x squared plus 4. So you say, let's say u is 2x minus 3 and v is x squared plus 4. So let's work out what is f dash x here. So f dash x will be, so v is x squared plus 4. So you write x squared plus 4, and then u dash. U dash means you differentiate the function u with respect to x. It's always good to write it down first rather than differentiating directly. So 2x minus 3, so this will avoid making any mistakes, minus then u is in brackets 2x minus 3, and then differentiate v is x squared plus 4, everything divided by v squared, so x squared plus 4 whole square. Okay, now let's differentiate. So you have x squared plus 4, and derivative of 2x minus 3 will be just 2, minus 2x minus 3, and the derivative of x squared plus 4 will be 2x over x squared plus 4 whole square. Okay, now we have to expand and simplify. So we multiply 2 inside x squared plus 4, so it becomes 2x squared plus 8. And then let's say this is 2x and there is a minus sign, so let's say we multiply minus 2x inside. So minus 2x times plus 2x will be minus 4x squared, and then minus 2x times minus 3. Minus minus becomes plus, and then 2 times 3 will be 6, and then x all over x squared plus 4 whole square. That means if we simplify it further, it becomes 2x squared minus 4x squared becomes minus 2x squared, and then plus 6x plus 8 over x squared plus 4 whole square. Now if you compare with, so we were needed to find out in this form. So a will be minus 2, b will be plus 6, and c will be plus 8. Okay, so that's your first question. Now question B is, hence using algebra, find the values of x for which f is decreasing. So a function is decreasing if the f dash x, so this is the condition for decreasing function, so f dash x is less than 0. Now f dash x is this function here, so if you write minus 2x squared plus 6x plus 8 over x squared plus 4 whole square less than 0. Now the denominator is a positive number, so if we multiply that on both sides, then you simply get minus 2x squared plus 6x plus 8 less than 0. Okay, now we need to solve this inequality. So let's divide both sides by minus 2. So let me write it down. Minus 2x squared plus 6x plus 8 less than 0. Now if we divide both sides by minus 2, so whenever in an inequality, if you multiply or divide by a negative number, then you have to change the inequality sign. Like for example, if you consider 2 is greater than minus 3. Now, if you multiply by minus 1 on both sides, then it becomes minus 2, and this becomes plus 3. Now this becomes bigger. So you see, when you multiply by a minus 1 on both sides, then you have to change the inequality sign. So same thing is valid here. If we divide by minus 2, so this becomes x squared plus 6x divided by minus 2 will be minus 3x plus 8 divided by minus 2 will be minus 4 less greater than 0. Now you have to change the inequality sign. Now we have to solve this inequality. So if we think of the factors of minus 4 will be minus 1 times plus 4 or 1 times minus 4. Now we want those two factors whose sum is same as b. b is minus 3. So I think if you do 1 plus minus 4 will give you minus 3. So the two factors are 1 and minus 4. That means this can be written as x plus 1 and x minus 4 greater than 0. Okay. Now if you think of this as an inequality, this is a very quick trick. If so you have, so if you say this was equal to 0, then this will give you 2 roots minus 1 and x equals plus 4. Okay, so minus 1 is here and plus 4 is here. So if we draw, this is just a rough diagram. So anything above 4 will be positive, anything in between minus 1 and 4 will be negative, anything below minus 1 is positive. So we want this to be positive. That means when x, either x is less than minus 1 or x is greater than 4, that will give you the product of these two factors greater than 0. Okay, so this is a quick way to draw the graph of the quadratic function. Let's quickly confirm the answers. So I think the answers are here. So minus 3x squared plus 6x plus 8, that's correct. And then either x is less than minus 1 or x is greater than 4. So our answers are correct. Yeah, x is less than minus 1 or x is greater than 4. Okay, let's quickly confirm the answers. So I think the answers are here. So minus 3x squared plus 6x plus 8, that's correct. And then either x is less than minus 1 or x is greater than 4. So our answers are correct. Yeah, x is less than minus 1 or x is greater than 4. Question 6. Figure 1 shows a sketch of the graph with equation y equals 3 modulus x minus 2 plus 5. The vertex of the graph is at the point P shown in figure 1. So this is P here. Find the coordinates of P. Okay, so the quickest way to work out the coordinates of P, so this is a modulus function. It makes everything positive. So whatever value of x, this will come out as positive, or minimum it can be 0. So it will be greater than or equal to 0. So this is the minimum point P. So therefore when x minus 2 is 0, that will give you x equals 2 and y equals 5. So if this becomes 0, then y becomes 5. So the coordinates of this turning point of P will be 2, 5. Okay. Now question B, solve the equation 16 minus 4x equals 3 modulus x minus 2 plus 5. Okay, so if we say like solving this, or you can say there are two ways to do this. So one method will be where you open the bracket with a positive sign, and one time you open the bracket with a negative sign. So we can try with that. The other method is to find the equations of each of these legs and then solve with this one here. So we'll see both methods, how they work, and then move forward. So let's start with the first one. So first we work out, so like solving these two equations means solving 16 minus 4, y equals 16 minus 4x and y equals 3 times modulus x minus 2 plus 5. So you're basically solving them simultaneously and finding where the two graphs intersect each other. So let's try the first method where we work out the equations of each of these lines. So this line has a positive slope, so let's open the modulus with a positive sign. So this becomes y equals 3x minus 2 plus 5. So this becomes y equals 3x minus 6 plus 5, and then y becomes 3x minus 1. Okay, so this is the equation of this leg here. And the other leg here, this one, so we open with a negative sign. So y equals 3 times, let's say put a minus sign here at the front, x minus 2 plus 5, and this becomes minus 3x plus 6 plus 5. So this becomes minus 3x plus 11. So y equals minus 3x plus 11 is the equation of this leg here, and y equals 3x minus 1 is the equation of the right leg. We could have figured out the point P by solving these equations simultaneously as well. That's another method to find the coordinates of P. Now let's solve each of these with this equation, with this line. So this is roughly like if you think y equals 16 minus 4x, so this gradient is negative and the y-intercept is 16. So first of all, the y-intercept of this point is 16 here, of this line, sorry, and then the y-intercept of this one is 16. Yeah, and the line will be roughly, we will find out if we have this kind of line or because the gradient is more. So let's see if we can draw it more accurately. Let me see. So the gradient of this line is minus 4. So this is minus 3, minus 4 will be like this. So minus 4 will be something like this. So we will figure out if the two lines intersect each other or not. So let's solve the two equations. So let's say we solve with the left one. So 16 minus 4x equals minus 3x plus 11. So let's take the minus 4x to the right and bring the plus 11 to the left. So it becomes 16 minus 11 equals minus 3x plus 4x. So this becomes x equals 5. Now this leg is only defined up to this point where the x coordinate is 2. So that means these lines will intersect, but that is beyond the point 2. So we will reject this solution. Okay. Now let's solve the other one. So you have 3x minus 1 equals 16 minus 4x.
So this will give you, take the minus 4x to the right, bring the minus 1 to the left. So it becomes 16 plus 1 equals 3x plus 4x. So this is 7x equals 17. That means x equals 17 over 7. So find the coordinates of, solve the equation. So the only solution for this equation will be x equals 17 over 7. Okay. Now, part C, a line L has equation y equals kx plus 4. So I just put it this 2 and this is 5 and this is 2. Okay. Now line L has equation y equals kx plus 4, where k is a constant. Given that L intersects y equals 3 times modulus x minus 2 plus 5 at two distinct points. So this line was y equals 3x minus 1, and this line was y equals minus 3x plus 11. Okay, now there is a line L, y equals kx plus 4. So kx plus 4, the y-intercept will be 4. Let me change the color of my pen. So let's say I use blue. Okay, now so this line has gradient 3. Now this line y equals kx plus 4, the y-intercept is here. Okay, now so y equals kx plus 4. So now think about the line intersect at two distinct points. So if the line passes through this point, then this will be the this will intersect this graph at only one point. Okay, so let's work out what is excuse me. So if we put, like, if it passes through this point, then let's work out k for this when you substitute this point here. So x is 2, y is 5, so k times 2 will be 2k plus 4. So this comes out as 5 minus 4 equals 2k. K is 1 over 2 half. Okay, so k is the gradient. Now if the gradient is less than half, then it will not intersect this line at all. So the value of k must be greater than half. Now let's see what is the maximum value of k. Now the maximum value of k, imagine like there is another line. If you have a line like this that intersects, so we need to find out until when this line intersect this line here. Okay, so that means if the gradient is less than 3, if the value of k is less than 3, then there is a guarantee that the line will intersect this line here and this line here. So you will get two distinct solutions. So that means the maximum value of k will be less than 3. If k becomes equals to 3, then that becomes parallel and they won't intersect. So k must be less than, and anything k more than 3 will only intersect at one point. Okay, so let's have a look at the answers now. So first one is 2, 5, 17 over 7, and k must be between half and 3. So I hope you understood the question.
Question number 7. Figure 2 shows a cylindrical tank of height 1.5 meters. Initially, the tank is full of water. The water starts to leak from a hole at a point L in the side of the tank. So this is the point L. While the tank is leaking, the depth h meters of the water in the tank is modeled by the differential equation dh over dt equals minus 0.12 e to the power minus 0.2 t, where t hours is the time after the leak starts. So t is in hours. It's important to note the units here. Now show that h is equal to a e to the power minus 0.2 t plus b, where a and b are constants to be found. Okay, so for the first question, so we have to basically solve this differential equation to get the values of a and b. So first thing I will write it down. So initially when t is 0, the water was, so initially the tank is full of water. So when time is 0, the value of h will be 1.5 meters. We may need this information later. So now we start with dh over dt equals minus 0.12 e to the power minus 0.2 t. So we separate the variables, so we multiply dt on both sides. So dh can be written as minus 0.12 e to the power minus 0.2 t dt, and then we integrate on both sides. So integral dh, we take the constant out of the integration to integral e to the power minus 0.2 t dt. Now integration of dh, so assume there is 1 dh, so the integration of 1 dh will be h equals minus 0.12 times. Now this is e to, so integration of e to the power x dx is e to the power x, and if you have integration e to the power ax plus b dx, then this is of the form integral f dash ax plus b. So the integration of this is uh, f of f of ax plus b, and then you times it by 1 over a. Okay, so integral e to the power ax plus b, integration will be e to the power ax plus b and times by 1 over a. So this integration will be minus 1 over minus 0.2 and e to the power minus 0.2 t plus a constant. So then h can be written as 0.12 divided by 0.2. So if I quickly divide, 0.12 divided by 0.2 is 3 over 5, which is 0.6. So this is 0.6 e to the power minus 0.2 t plus c. Now we need to work out c. So we use this initial condition we have mentioned in the beginning. At t0, h is 1.5. So you put 1.5 equals 0.6 e to the power, when you put t0, this becomes 0 plus c. Now e to the power 0 is 1, so 1.5 equals 0.6 plus c. That means c is 0.9. So your final equation will be h equals 0.6 e to the power minus 0.2 t plus 0.9. That means if we compare with this here, that means a is 0.6 and b is 0.9. Okay, yeah. Now let's do part b. So find the time taken for the depth of the water to decrease to 1.2 meters. So basically they are saying when h is 1.2 meters, you need to work out the time in hours and minutes to the nearest minute. It's important to read this information here. So you have to give your answer in hours and minutes to the nearest minute. Okay, so we have h is equal to 0.6 e to the power minus 0.2 t plus 0.9. Now if we just put h as 1.2 equals 0.6 e to the power minus 0.2 t plus 0.9, subtract 0.9 from both sides, so 1.2 minus 0.9 will be 0.3. We don't need to show so many steps, you can simplify this quickly. So this will be 0.3 and we divide both sides by 0.6, then this becomes e to the power minus 0.2 t. So 0.3 divided by 0.6 is half, equals e to the power minus 0.2 t. So this, now take ln on both sides, so ln half equals, so when you take ln here, so the power will come to the front. That means t will be 1 over minus 0.2 ln half. Now let's calculate the value of ln half 0.5 and then divided by minus 0.2. So that comes out as 3.466 hours. So we need to change this in. So this you can say that 3 hours plus 0.466 hours. So 0.466, if we times it by 60, that comes out as 27.96. So 27.96 to the nearest minute will be 28 minutes. So your final answer will be 3 hours and 28 minutes for part B. Okay, we'll check the answers at the end. So now last part, in the long term, the water level in the tank falls to the same height as the hole. Find according to the model. So in the long term means when t is very large. So when t is large, you can say t is infinitely large, then h is 0.6 times e to the power minus 0.2 t plus 0.9. So when t is infinitely long, the water level in the tank falls to the same height as the hole. So this becomes h here. So we need to find according to the model the height of the hole from the bottom of the tank. So when t is infinitely large, so the value of this function, the exponential function will be like if you sketch the graph of y equals e to the power minus x, e to the power minus x graph is something like this. When x tends to infinity, this value tends to 0. That means when t is infinitely large, then e to the power minus 0.2 t will tend towards 0. Okay, so we just replace this whole thing with 0, then h will be 0 plus 0.9, so h will be 0.9 meters or 90 centimeters. Let's quickly check the answers now. So 3 hours and 28 and 0.6 and 0.9. So 0.6 and 0.9, that's correct. And 3 hours and 28 minutes and 0.9 meters. So 90 and 3 hours and 28, that's correct. And this is also correct. Question 8. The functions f and g are defined by fx equals 4 minus 3x squared, where x belongs to all real numbers, whereas g of x is equal to 5 over 2x minus 9, where x belongs to all real numbers except x is not equal to 9 over 2. Find f of g of 2. So to work out f of g of 2, first we will work out what is g of 2. So we will use the function g of x. So you just replace x by 2. So 2 times 2 minus 9. So 5 over 4 minus 9, which is minus 5. So this is minus 1. Now this is minus 1. So you need to work out f of minus 1. Now we use the function f to work out f of minus 1. So 4 minus 3 times minus 1 square. So this will be 4 minus 1 square is 1. So 4 minus 3, this is 1. So f of g of 2 is 1. Okay, so that's part A. Now part B, so find g inverse. So to find g inverse, you can first replace g of x as y equals 5 over 2x minus 9. Now swap x and y. So you can write x equals 5 over 2y minus 9. Then multiply both sides by 2y minus 9. Now we need to make y the subject here. So 2y minus 9 times x equals 5. Then you expand the brackets, so it becomes 2xy minus 9x equals 5. Then you add 9x on both sides. So this becomes 2xy equals 5 plus 9x. And then you divide both sides by 2x. So y becomes 5 plus 9x over 2x. So this is the g inverse x function. Okay, now question C1. So move to the next slide. C1 is find f of g of x, giving your answer as a simplified fraction. So g of fx. So g of fx is 4 minus 3x squared. So in your gx function, you replace x by 4 minus 3x squared. So 5 over 2 times x is replaced by 4 minus 3x squared minus 9. So this becomes 5 over 2 times 4 is 8 minus 6x squared minus 9. So this becomes 5 over 8 minus 9 is minus 1 minus 6x squared. Now if we take minus common, so it becomes 5 over minus 1 common, so it will be 1 plus 6x squared. So deduce the range of g of f of x.
Okay, so we need to work out the range of g of fx. Okay, so g of fx we have calculated is here. So if we can rearrange this as minus times 5 over 1 plus 6x squared. Now think about this function here. So x squared is in the denominator. Now x squared is a positive. Square of any number is a positive number. Now the minimum value of x squared is always either 0 or greater than or equal to 0. So when x squared is 0, that means x is 0. So when x is 0, so the denominator will be minimum. That means 5 divided by the minimum denominator will give you the maximum value. And when you times by a negative number, that becomes the minimum value. So when x is 0, the minimum value will be minus 5. So just put x 0 here. So that will be the minimum value of g of fx. Now, as x increases, the denominator gets bigger and bigger. That means the numerator becomes smaller and smaller, like it becomes close to 0. So, and times by a negative number, it will still be close to 0. So, the maximum value of g of f of x will be 0. That means the range of g of f of x will be, so it will be maximum value is less than 0 and the minimum value is greater than or equal to minus 5. Okay, so the maximum value will be 0. Yep. Now let's have a look at the mark scheme, what the mark scheme says. So g of f of x is less than 0, and I think that these two commas, it probably means as g of f of x is greater than or equal to minus 5. Okay, now the function h is defined by h of x equals 2x squared minus 6x plus k. Find the range of values of k for which the equation f of x equals h of x. So h of x is 2x squared minus 6x plus k, and this is h, and then f of x is 4 minus 3x squared. Now find the range of values of k for which this equation has no real solution. So let's make a quadratic. So move the minus 3x squared to the left, becomes plus 3x squared. 3x squared plus 2x squared becomes 5x squared minus 6x plus k minus 4 equals 0. Now for this equation, in order to has no real roots, that means the discriminant, like if you have ax squared plus bx plus c equals 0, the discriminant is b squared minus 4ac. Now if the discriminant is less than 0, then this equation has no real roots. So find the range of values of k for which the equation has no real solutions. Now if we use the b squared minus 4ac, so a is 5, b is minus 6, and c is k minus 4. So if we use the discriminant, calculate the discriminant from this. So b square minus 6 square minus 4ac, 4 times a is 5 and c is k minus 4, and in order to this equation has no real roots, this must be less than 0. So this will be 36 and then minus 20 times k minus 4 less than 0. Let's divide by 4. So 4 times 5 is 20, 4 times 9 is 36, so 9. Now expand this, minus 5k, and minus 5 times minus 4 will be plus 20 less than 0. So minus 5k plus 29 less than 0. Now let's take minus 5k to the right, so it becomes 29 less than 5k. That means k is greater than 29 over 5. So that will be the answer to this question. Let's quickly verify. So 29 over 5 is roughly this number here. Okay.
Question 9. The first three terms of a geometric sequence are 3 to the power 4k minus 5, 9 to the power 7 minus 2k, and 3 to the power 2 times k minus 1, where k is a constant. Using algebra and making your reasoning clear, prove that k is 5 over 2. Okay, so this is a geometric sequence. So in a geometric sequence, the common ratio is the same. So if you have first term a, then the second term will be a times r, and the third term will be a r to the power 2. So one less power. And the nth term is basically ar to the power n minus 1. Now here, if we do the ratio of this term divided by this, will give you r. This term divided by this will give you r, and they both will be equal to each other. So let's say the common ratio r in this case will be given by 9 to the power 7 minus 2k over 3 to the power 4k minus 5, and this will be the same as 3 to the power 2 times k minus 1 divided by 9 to the power 7 minus 2k. There may be a simple way to figure out why k is 5 over 2, but we have to prove that using algebra as well. So now 9 can be written as 3 square is basically 9. So wherever we have 9, we can replace it with 3 square. So this 9 can be replaced as 3 to the power 2 whole power 7 minus 2k over 3 to the power 4k minus 5. And on the right hand side will be 3 to the power. Now let's expand the bracket, 2k minus 2 over 3 to the power 2 times 7 minus 2k. Okay, now we can simplify it further. So I'll write it down here. So this becomes 3 to the power 7 times 2 is 14 minus 2 times 2 is 4k. I've just expanded the bracket. And then a to the power m divided by a to the power n, we subtract the powers. So we just do 14 minus 4k minus this thing 4k minus 5. So by open the bracket, so 4k becomes minus 4k, and minus 5 when you open, like it was minus 4k minus 5. So when I open the bracket, it becomes minus 4k, and minus minus becomes plus 5. So that's the left hand side, and the right hand side will be 3 to the power 2k minus 2, and this becomes 2 times 7 is 14 minus 2 times 2 is 4k. And again, you subtract the power from the numerator, so there will be a minus sign here when you subtract from the numerator. So when you expand the bracket, will be minus 14 plus 4k. Now if we simplify this, so it becomes 3 to the power 14 plus 5 is 19, and minus 4k will be minus 8k equals 3 to the power 2k plus 4k will be 6k, and minus 2 minus 14 is minus 16. Now they both are powers of 3, so they must be equal. Powers must be equal because left hand side is same as the right hand side. That means 19 minus 8k will be same as 6k minus 16. Now let's bring the 16 to the side and take the minus 8k to the other. So 19 plus 16, same as like adding 16 to both sides and adding 8k to both sides. So 6k plus 8k. So 6k plus 8k is 14k, and this becomes 9 plus 6 is 15. 1 plus 2, 3. 1 plus 1 is 2 plus 1, 3. 35 over 14. That means k will be 35 divided by 14. If I divide both by 7, 7 times 5, 7 times 2. So k will be 5 over 2. So that's part A. Okay, now let's have a look at part B. So we know that k is 5 over 2, and remember common ratio will be this thing, so which is like the simplified version of this thing, this. So that means r will be, so we need the first term and the last term, first term and the common ratio. So r is 3 to the power 19 minus 8k. 3 to the power 19 minus 8k. If we substitute 3 to the power 19 minus 8 times 5 over 2, so 2 times 4, 4 times 5 is 20, so this becomes 3 to the power 19 minus 20, which is minus 1, which is 1 by 3. So that's r. And let's work out the first term. A will be 3 to the power 4 times k minus 5. So if we substitute 4 times k is 5 over 2 minus 5. So I will 2 times 1 is 2, 2 times 2 is 4, 5 times 2 is 10, minus 5 will be 5. So this becomes 3 to the power 5. Now hence find the sum. So part B is hence find the sum to infinity of the geometric sequence. Now we know that r is less than 1 by 3, less than 1. That means sum to infinity, we can use the formula for the sum to infinity, which is a over 1 minus r. This formula is only valid when mod r is less than 1, or you can say r is greater than minus 1, less than 1, which in this case, yes. So S infinity now will be a. A is 3 to the power 5 over 1 minus r. R is 1 by 3. So let's multiply the numerator and denominator by 3. So this becomes 3 times 3 to the power 5 and times by 3. So it will be 3 minus 1. So this becomes 3 to the power 6 over 2. Now let's work out this 3 to the power 6. 3 to the power 6 is 729 divided by 2. The answer is 364.5, or as a whole, as a fraction, 729 over 2. Let's check the answer quickly. Yeah, so that's the sum, and k is 5 over 2. Question 10. So here is the diagram given in the question. And the question is, in this question, you must show all the stages of your working. Solutions relying entirely on calculator technology are not acceptable. Figure 3 shows a sketch of part of the curve with equation y equals 8x minus x to the power 5 over 2, and the condition is x is greater than or equal to 0. The curve crosses the x-axis at the point A. Verify that the x-coordinate of A is 4. So let's have a look. So A is here, crossing the x-axis, and that means the y-coordinate of A will be 0. So if we just put y 0, so this is the function y equals 8x minus x to the power 5 over 2. Now if we put y 0, this becomes 8x minus x to the power 5 over 2. Move minus x, so x to the power 5 over 2 to the left, so it becomes x to the power 5 over 2 equals 8x. Now we square on both sides. Square on both sides. So this becomes x to the power. You multiply the power, so 5 over 2 times 2 will be just 5. And then 8x whole square becomes 64 x square. Now divide both sides by x square, so it becomes x to the power 5 divided by x square, which becomes x to the power 3 equals 64. Now cube root of 64 will be 4. That means the coordinates of A are x coordinate will be 4 and y coordinate will be 0 because it's crosses the x-axis. Now the line L1 is the tangent to the curve at A. Use calculus to show that the equation of line L1 is this. Now L1 is a tangent to the curve, so the gradient of the curve, you just have to differentiate this one. So if we differentiate this, so this will be dy over dx. Differentiation of 8x will be just 8 minus differentiation of x to the power 5 over 2. You bring the power at the front, and x to the power, you subtract 5 over 2 minus 1 becomes x to the power 3 over 2. Now here, so this is the gradient function. Now to find the gradient at a particular point, like point A, x coordinate is 4. So at x equals 4, or at point A, the gradient dy over dx will be 8 minus 5 over 2, and x is 4 to the power 3 by 2. So this becomes 8 minus 5 over 2. So square root of 4 is 2. 2 cube will be 8. So this is 8. So 2 times 4 is 8. So this becomes 8 minus 20, which is minus 12, which is also clear, like the gradient of line L1 is negative. Okay. Now we know the point A is 4, 0, and we know that the gradient of the line is, this is for the line L1, the gradient is minus 12. So if we use y minus y1, y1 is 0 equals minus 12x minus x1, which is 4. So this becomes y equals minus 12x plus 12, minus 12 times minus 4 will be plus 48. Now the form we want is 12x plus y equals 48. So just add 12x to the left. So 12x plus y equals 48. So that's the answer for part B. Yep. Now the region R shown shaded in figure 3 is bounded by the curve, the line L1 and line L2. Use algebraic integration to find the exact area of R. Now this line L2 is passing through the origin. That means the x coordinate is, the coordinates of origin are 0, 0, 0. So the gradient function was this one. If we just put x equals 0, then the gradient of line L2 will be 8. So for line L2, the gradient, so it passes through the point 0, 0, and the gradient m is, you just put in your dy over dx, if we just put x 0 here, then the gradient will be 8. So m is 8. That means the equation of line L2 is y equals 8x. Now if we just solve these two equations to find the point of intersection here, okay, so this is 4, 0. So this length is basically 4. Okay, and if we can work out the coordinates of this point of intersection, then that will give you, the y coordinate will give you the height of this triangle. So in order to find the area of the shaded region, if we can work out the area of the triangle minus the area of the curve, and the area of the curve between, like the area between the curve and the x-axis, we will be able to work out using integration. So let's work out the coordinates where the line L1 and L2 intersect. So this is L2, this is L1. You just replace y as 8x equals minus 12x plus 48. So this will give you 12x plus 8x will be 20x equals 48. That means x is 48 divided by 20. If we divide by 2, will be 24 over 10. That means x is 2.4. Now x is 2.4. Let's work out y. Y will be 8 times 2.4. So 8 times 4 is 32. 3, 8 times 2 is 16, plus 3, 19. So 19.2. So the y coordinate is 19.2. Okay, so x coordinate is uh, 2.4 and the y coordinate is 19 point, let's be sure, 19.2. So the y coordinate is 19.2. That means the height is 19.2. That means the area of the triangle will be base, which is 4, times height, which is 19.2, divided by 2. So this will be 2 times 2 is 4, 2 times 9 is 18, 1 carried over, 2 times 1 is 2, plus 1, 3. So 38.4 is the area of the triangle. Now let's work out the area of this curve, like between the curve and the x-axis. So the area will be given by integral 0 to 4 y dx, okay, which in this case will be 0 to 4. Y is 8x minus x to the power 5 over 2. Now if we integrate, so 8x integration will be x squared by 4 minus x to the power 5 integration will be x to the power 5 by 2 plus 1 becomes 5 by 2 plus 1, or you can say 5 by 2 is 2.5 plus 1 becomes 3.5 over 3.5. Okay, so 4 times 2 is 8. Overall 0 to 4. So your integration will be 2x squared minus x to the power 3.5 over 3.5, and then the limits are from 0 to 4. So if we put x equals 4 here, so this becomes 2 times 4 square minus 4 to the power 3.5 over 3.5 minus, when you put 0, everything becomes 0 because you have x squared and x terms here. So this will be, so if you simplify this, for this we can use calculator. We can maybe simplify, oh that's fine. So 4 times 4 is 16, times 2 is 32. Take away 4 to the power 3.5 divided by 3.5. That comes out as 256 over 7. Now if we do 32 minus 256 over 7, that comes out as minus 32 over 7. So why is that? So let's have a look. 5 by 2 is 2.5 plus 1 is 3.5 over 3.5. So x squared, oh, that's the mistake. Okay, so let's fix this. So when you integrate x, will be x to the power 2 over 2. So this will be 2 and this will be 4. So this will be 4x squared. Okay, so you do 4 times 4 squared. So you need to you do 4 times 4 is 16, times 4 is 64. So it's okay. I mean, we do make mistakes. So I was getting a negative area here. So that means I made some mistake. Okay, so these are not pre-planned. Like I don't practice these questions in advance, so I'm just doing it directly. So there is possibility that you can make mistakes, but you need to quickly find out the fix. Okay, so this could happen during the exam. So I was getting a negative answer, so I quickly checked and I found the mistake here. So now if we do 64 minus 256 divided by 7, that gives me 192 over 7. So this is the area of the curve. Now the area of the triangle is 38.4. So the area of the shaded region will be 38.4 subtract 192 over 7. 192 over 7. So if we do 38.4, take away 192 divided by 7 is 384 over 35. So I think you need to find the exact area of R. So this is 384 over 35. Let's check the answer now. So 384 over 35. That's correct. Well done. Question 11. Figure 4 shows the design of a badge. The shape ABCOA, ABCOA is a semicircle with center O and diameter 10 centimeters. So the diameter is 10 centimeters. That means the radius is 5 centimeters. So this is 5, this is 5. OB is the arc of a circle with center A and radius 5 centimeters. So this is like, imagine if it was a circle going like this. Okay. The region R shown shaded in figure 4 is bounded by the arc OB, the arc BC, and the line OC. Find the exact area of R. Give your answer in the form A root 3 plus B pi centimeter square, where A and B are rational numbers. Okay, so for this question, so if we can find out the area of the semicircle, that's the first thing we'll do. So the area of the semicircle ABCOA will be the total area. Total area will be, so if it was a complete circle, it will be pi r squared, but this is a semicircle, so you divide by 2. So pi times radius, as we have already figured out, is 5. So pi times 5 squared divided by 2. So this is 25 pi over 2. So that's the area of the entire region. Now we need to figure out the area of this this arc. Okay, so for this, if we join this with here, okay, and so this will be the radius also, so this will be 5 as well, and if we join this, so this will form an equilateral triangle, so this will be 5 as well. Okay, so that means this angle will be 60 degrees. It's an equilateral triangle, and this will be 60 as well. So it's very easy to work out the area of this equilateral triangle. So if we say triangle ABO, the area, if we use the formula for the area of a triangle, is half AB sine C, half times AB, so 5 times 5 times sine 60 degrees. Sine 60 is root 3 by 2, so this will be 25 over 2 times sine 60 is root 3 by 2. So this becomes 25 root 3 over 4. So that's the area of this triangle. Now looking at this, it looks like these two arcs, these segments, sorry, these two segments, they have an equal area because everything looks symmetric here. So that means to work out the area of this segment, let's say this segment here, we use the formula for the area of a segment. So area of a segment, so we use the formula r square. So the formula for the area of the sector, this whole sector ABOA, this whole sector here, will be r square theta by 2, and minus the area of the triangle, which is r squared sine theta by 2, which is what we have calculated previously. So this will be 25 root 3 by 4. Now this theta, this formula, this theta must be in radians. So that means the angle is 60 degrees, which is, if you times by pi over 180, will be 1/3 pi over 3. So we will use theta as pi over 3 in this formula here. So the area of this little portion, this segment here, will be r squared theta by 2 minus 25 over. So r is 5. So 5 square times 5 square times theta is pi over 3. Everything divided by 2 minus 25 root 3 divided by 4. That means this becomes 25 by 2 times pi over 3 minus 25 root 3 over, you can split this as 2 times 2. 4, this 4 can be written as 2 times 2. So this is the area of this little segment, or this segment will be the same as well. So we know the area of the segment and we know the area of the triangle. So if we have to figure out, so this one will be, leave it like this, 25 pi over 2, 25 pi over 6 minus 25 root 3 over 4. So that's the area of this tiny segment. Okay, and we know the area of the triangle. Triangle is, so if we have to times this by 2 to get these both segments here, this plus this will be times 2 plus the area of the triangle, which is 25 root 3 divided by 4. Okay, it's 25 root 3 divided by 4. So this will be the total area of this unshaded region. Okay, now we know that the total area of the semicircle is 25 pi over 2. If we subtract this, let's simplify this first. So this is, if you times by 2, so this becomes 25 pi over 3. So if you times by 2, becomes 25 pi over 3 minus 2 times 25 root 3 over 4, and then we have plus 25 root 3 over 4. So this becomes 25 pi over 3 minus, you can treat this as minus 2a plus a will be minus a, so minus 25 root 3 over 4 will be the area of this non-shaded region. Now if we subtract the total area from the semicircle, which is 25 pi over 4, 25 pi over 2, sorry, this is 2, 25 pi over 2 minus this one here, 25 pi over 3 minus 25 root 3 over 4. Okay, I hope we are doing it correctly. So now you can expand the bracket, so it will be 25 pi over 2 minus 25 pi over 3, and minus minus becomes plus 25 root 3 over 4. Okay, now if we simplify this, so this becomes 3 minus 2 will be 1, so this becomes 25 pi over, if you do 25 over 2 minus 25 over 3 becomes 25 pi over 6 plus 25 over 4 root 3. So if you write the way they want, so this is the area of the region R. So this becomes 25 by 4 times root 3 plus 25 over 6 times pi. So A will be this and B will be this. Okay, let's check the answer quickly. So 25 over 4 and 25 over 6. So 25 over 4 and 25 over 6. So I hope to understand the question.
Question 12a. Express 140 cos theta minus 480 sin theta in the form k cos theta plus alpha, where k is greater than 0 and alpha is between 0 and 90 degrees. State the value of k and give the value of alpha in degrees to 2 decimal places. Okay, so to do this question, we need to expand this using the cos formula, cos a plus b formula. So if we expand this, this will be k cos theta cos alpha minus k sine theta sine alpha. Now if we compare with this, so k cos alpha will be 140, and then there's minus 480 sine theta, so k sine alpha will be 480. Now to find k and alpha here, to find k, we square on both sides and add. So k square cos square alpha plus k square sine square alpha. You don't need to memorize any formulas here, so just follow this trick. 140 square plus 480 square. Then factorize this, so cos square alpha plus sine square alpha equals, now do 140 square, 140 square plus 480 square, that gives me 250,000. Now this is 1, so this becomes k square equals 250,000. Then k will be square root of 250,000, which is square root of the answer is 500. So k is 500. Okay, now to work out alpha, what we do is we divide this one by this one. So k sine alpha divided by k cos alpha. K sine alpha divided by k cos alpha equals 480 divided by 140. So k cancel, sine alpha over cos alpha is tan alpha equals, cancel the zeros, 2 times 24, 2 times 7, so 24 over 7. That means alpha will be tan inverse 24 over 7, which is shift tan inverse 24 divided by 7. Remember, this is in degrees, so make sure you have degrees mode in your calculator. So this gives me, we need to give the answer 2 decimal places. That means alpha is 73.74 degrees. Okay, so yep, that means k is 500 and cos theta plus 73.74 degrees. So this thing can be written as this. Okay, now let's do the next part. So a scientist studies the number of rabbits and the number of foxes in a wood for 1 year. The number of rabbits R is modeled by the equation, this one. So it looks like this part is the same as this thing here, which can be written in this form. So we will be using that form over here, where t months is the time after the start of the year and a is a constant. Given that during the year, the maximum number of rabbits in the wood is 1500. Find a complete equation for this model. So first thing, let's rewrite this as r equals a plus 500, and theta is 30t, so you can write cos 30t plus alpha, and alpha was 73.74 degrees. Just double check, 73.74. So now question says the maximum number of rabbits is 1500. So the maximum will be when the cos graph is like the maximum value is 1, minimum value is -1. So if we take the max of cos is 1, that means r is 1500 when this is 1. So this will be a plus 500 times 1, so it's just 500. That means a is 1000. Okay, So the complete equation for part A will be R equals 1000 plus 500 cos 30t plus 73.74 degrees. Okay. Hence, write down the minimum number of rabbits in the wood during the year according to the model. So the minimum will be when this thing is -1. So R min will be 1000 minus 500, which is 500. Okay. Now, the actual number of rabbits in the wood is at its minimum value in the middle of April. So middle of April is like half the month. So you will count this as half month. So use this information to comment on the model for the number of rabbits. So let's work out. So use this information to comment on the model for the number of rabbits. So one thing here is the maximum were 1500 and the minimum were 500. So April is like January, February, March, and mid-April, so 3.5 months. So if we put t as 3.5, the value of t in here as 3.5, and then calculate the value of r. So r will be 1000 plus 500 times cos 30 times 3.5 plus 73.74 degrees. So let's work out. So if we get a realistic number here, then we can say that this model is okay. If not, then this model is not good. So let's see, cos 30 times 3.5 plus 73.74, bracket close. I work out this value and then I times this by 500, which is roughly minus 499, and then add 1000. So this gives me roughly 500.12, which is roughly 500. So yeah, so this is kind of the minimum value, and minimum value is 500. So this is what we get, roughly same. So that's, this model is still valid. Okay. Now, next part, the number of foxes f in the wood during the same year is modeled by this equation. The number of foxes is at its minimum value after t months. So the minimum value of foxes will be when this is -1, because sine is max is +1 and min is -1. So if you think about the sine graph, the max value and the min value, so the min value of sine graph -1 will be 270 degrees. So this is 180, this is 90, 360. So this is the sine graph. That means when like this 30t plus 70 is 270 degrees, then this will give us the value of capital T. So we can write 30 times capital T and then subtract 70 from both sides. That will give us 200. That means T is 200 divided by 30. Cancel the zeros. So T is 20 divided by 3. Okay, now find, according to the model, the number of rabbits in the wood at time t months. So all we have to do is substitute the value of t in here. So that means R will be 1000 plus 500 times cos 30 times 20 over 3 plus 73.74. So 3 times 10 is 30, so that becomes 200. That becomes 273.74. So cos 273.74, that gives me 0.065. And if I times this by 500 and then add 1000, so that gives me 1032.61. So find according to the number of rabbits. So number of rabbits will be, cannot have 0.61, so you can say 1032. Let's check the answers now. So first one is K is 500, alpha is 73.74, then 1000, min value is, so this is, yeah, you can write in this form, that's what we have. And R min will be 500, and we got 500.1, so the model is reliable. Then this gives us T equals 20/3, and this gives us 1032. So all the answers are correct. Well done. Okay. Question 13a. Given that a is a positive constant, use the substitution x equals a sine square theta to show that integration 0 to a x to the power half is square root of a minus x dx equals half a square integral 0 to pi over 2 sine square 2 theta d theta. Okay, so x is supposed to be a sine square theta for this substitution. Okay, now first thing we will change the limits. So when x is 0, if we substitute 0 here, so 0 equals a sine square theta, and this will give you sine square theta equals 0. If we divide both sides by a, that means sine theta is 0, that means theta is 0, so sine 0 is 0, so theta is 0 degrees. Now when x is a, then a equals a sine square theta, and that means sine square theta is 1, that means sine theta is plus 1. That means theta, now if you look at the sine graph is like this, so at pi over 2 the value is plus 1, so that means theta is pi over 2. So these are the limits for theta from 0 to pi over 2. Now next thing is we need to use this substitution. So x to the power half times square root of a minus x dx integral 0 to a. Now if we change, so x to the power half, if you take a square root on both sides, then square root of x becomes square root of a times the square root of sine square theta becomes square root of a sine theta. So that's one thing. We're going to need x to the square root of x is same as writing x to the power half. Now if we substitute for a square root of a minus x, so a minus x, x is a sine square theta. Now if we factorize this, take a common, this becomes 1 minus sine square theta. Now 1 minus sine square theta is same as saying cos square theta, so this becomes the square root of a cos theta. Okay, so that's for this part. This part is here and this part is here. Now we need to replace dx as well, so let's differentiate dx with respect to theta. So dx over d theta becomes, a is a constant, sine square theta will be 2 sine theta, and differentiation of sine theta will be cos theta. And if we multiply both sides by theta, so dx becomes 2a sine theta d theta. Now we have everything, so let's substitute integral 0. So when x is 0, theta is 0. When x is a, theta is pi over 2. And then x to the power half is same as saying square root of a sine theta, and square root of a minus x is square root of a cos theta, and dx is 2a sine theta, I think I missed it, sine theta cos theta d theta. So dx is 2a sine theta cos theta d theta. Okay, now square root of a times the square root of a becomes a, and then a times a becomes a square. Okay, and we can also multiply by 2 and divide by 2. I'll tell you why we need that. So if we take the a square out, so it becomes half a square integral 0 to pi over 2. and then 2 sine theta cos theta becomes sine 2 theta, and this 2 sine theta cos theta becomes also sine 2 theta. That means sine 2 theta times sine 2 theta becomes sine square 2 theta. So I think that's what we were supposed to prove. So that's correct. Okay, so that was part A. Now let's have a look at part B. So hence use algebraic integration to show that 0 to a, this thing can be written as k pi a square. Okay, so we will use the outcome from part A, which is square root half a square, 0 to pi over 2, and sine square 2 theta d theta. Now whenever you have like sine square or cos square, we have to use the cos 2 theta, like the cos double angle formula, which is cos 2 theta is basically, there are three different forms of it: cos square theta minus sine square theta, or 2 cos square theta minus 1, or 1 minus 2 sine square theta. So they all are equal to cos 2 theta. Cos 2 theta. Now if you make sine square theta the subject from here, one thing, like this is sine square 2 theta, so if we replace theta as 2 theta here, then let me do that. So this becomes cos 4 theta equals 1 minus 2 sine square 2 theta, in order to match with what we have here. Now if we make sine square 2 theta the subject, sine square 2 theta equals 1 minus cos 4 theta over 2.
Okay, so now we replace 0 to pi over 2 sine square 2 theta. We can write it as 1 minus cos 4 theta over 2 d theta. Okay, take the 2 out, so it becomes 1 by 4 a square, uh, 0 to pi over 2 1 minus cos 4 theta d theta. Now let's integrate this. So this becomes 1 by 4 a square. Integration of 1 becomes theta, and integration of cos 4 theta. So differentiation of sine theta is cos theta. So when you integrate cos theta, it will give you sine theta, but this is of the form f dash ax plus b. When you integrate f dash ax plus b is 1 over a f of ax plus b. So the integration of cos 4 theta, so there's already a minus sign. Integration of cos 4 theta would be 1 by 4 sine 4 theta, and the limits are 0 to pi over 2. So let's substitute this here. Let's substitute the limit. So 1 by 4 a square. Now when you put pi over 2, so this is pi over 2 minus uh, 1 by 4 sine 4 times pi over 2 becomes sine 2 pi, which is 0. So I put 0 here, minus, now you put the limit 0. So when theta is 0, minus sine 1 by 4 sine 4 times 0 is sine 0, which is 0. So this is all 0. The only thing left is pi over 2. So this becomes 1 by 4 times pi over 2 becomes 1 by 8 pi a square. That means if we compare this with k here, that means k is 1 by 8. So that's the answer for this one. Let's have a quick verification here. So yeah, k is 8, 1 over 8. Yeah, so that's correct. Okay.
Question 14. A balloon is being inflated. In a simple model, the balloon is modeled as a sphere, so the balloon is inflated here, yeah? It's not decreasing, it's increasing in size. In a simple model, the balloon is modeled as a sphere. The rate of increase of the radius of the balloon is inversely proportional to the square root of the radius of the balloon. At time t seconds, the radius of the balloon is r centimeter. Write down a differential equation to model this situation. So here what we do is, so the rate of increase of the radius of the balloon, so dr over dt, is inversely proportional to the square root of the radius of the balloon. So we put a constant of proportionality and square root of radius. So I think that's the answer for the first one. Now at the instant when t is 10, the radius is 16 centimeter. The radius is increasing at the rate of 0.9 centimeter per second. So when t is 10, so we know a few things. We know the radius is 16 centimeters and the radius is increasing at the, so dr by dt is basically 0.9 centimeter per second. Okay, so solve the differential equation. Okay, so we will need these conditions to find the constant. So let's first separate the variables here. So you can multiply square root of r there, dr equals k dt, and then we integrate. So r to the power half, square root of r can be written as r to the power half, which can be integrated as r to the power half plus 1, which is r to the power 3 by 2 divided by 3 by 2 equals kt plus c. Now what we do here is we rewrite this as 2 over 3 r to the power 3 by 2 equals kt plus c. Now let's try to work out the constant. So in the first equation here we have r and dr by dt, so let's use that. So r is 16. Yep, so we do dr by dt is 0.9 equals k divided by square root of 16. That means 0.9 equals k divided by 4. That means k is 4 times 9 is 36, so 3.6. So k is 3.6. Now we replace k in this equation here as 3.6. So 2 by 3 r to the power 3 by 2 equals 3.6 t plus c. Now let's substitute the value of t and r in here. So 2 by 3, r is 16 to the power 3 by 2 equals 3.6 times 10 plus c. So 16 square root is 4, cube is 64. 64 times 2 will be 128. So this becomes 128 over 3 equals 36 plus c. That means c will be 128 divided by 3. 128 divided by 3 minus 36. So that comes out as 20 over 3 in the calculator. That means the equation is, we can rewrite the equation, 2 by 3 r to the power 3 by 2 equals 3.6 t plus c. C is 20 over 3. So let's multiply by 3 on both sides. So this becomes 2r to the power 3 by 2 equals 3.6 times 3.6 times 3 is 10.8 t plus 20. Then we divide everything by 2. So r to the power 3 by 2 becomes 5.4 t plus 10. So that's the final equation. I believe this is what we were supposed to prove. Okay, so let's have a look at question C now. Now, hence find the radius of the balloon when t is 20. So all we have to do is put t equals 20 here. So r to the power 3 by 2 equals 5.4 times 20 plus 10. Then this becomes 5.4 times 20 plus 10 is 118. So r to the power 3 by 2 is 118. Then r will be 118 to the power. So what we do whole power 2 by 3 on both sides. So 118 to the power 2 divided by 3. So 118. So take the answer and put the power as 2 divided by 3. That gave me 24.06 or 05. Now we want to give, this is in centimeters, we want to give your answer to the nearest millimeter. So nearest millimeter, so imagine this is like, if you want to change this in centimeter, will be in millimeters will be 240.6 millimeters. Now if you want to give your answer to the nearest millimeter, so this is 6 more than 5, so that means this will go up, so it will be 241 millimeters, or you can say 24.1 centimeters. Now suggest a limitation of the model. So according to the model, as the time increases, the radius is increasing. Now it's not possible for the balloon to keep inflated, because at some point it will burst out. So that's the limitation of this model. Let's have a look at the answers. So first one was a proof, and the second one is 24.1 centimeter, and the model will not hold infinitely as the balloon may burst. Yeah. Okay. Question 15, part 1. Show that k square minus 4k plus 5 is positive for all real values of k. So what we can do here is we can try to do the complete square form. So complete square form for this will be, so remember, complete square form is if you have x square plus bx, then this can be written as x plus half of b whole square minus b by 2 whole square. So we'll use this here. So you have b as minus 4, so it will be k minus 2 whole square minus 2 whole square and then plus 5. So this becomes k minus 2 whole square minus 2 square is 4 plus 5. So this can be written as k minus 2 whole square plus 1. Now this is a square, so this is always going to be positive, or minimum can be 0. And then if you add plus 1, then it becomes greater than or equal to 1. So this is always going to be a positive for all real values of k. This expression is going to be a positive for all real values of k, for any values of k here. Okay. Okay, now question 2. A student was asked to prove by contradiction that there are no positive integers x and y such that 3x this times this equals 28. The start of the student's proof is shown below. Assume that positive integers x and y such that 3x plus 2y times 2x minus 5y is 28. If 3x plus 2y equals 14 and 2x minus 5y equals 2, so he used these two factors, 14 and 2, for 28 and solved them, and then not integers. Show the calculation statements needed to complete the proof. Okay, so I think he started correctly, but then he didn't consider all the pairs. Like 28 can be 1 times 28, or 28 times 1, or minus 1 times minus 28, or minus 28 times minus 1. The other possibility will be 2 times 14, 14 times 2, minus 2 times minus 14, minus 14 times minus 2. And then 4 times 7 is 28, 7 times 4, minus 4 times minus 7, and minus 7 times minus 4. So these are the other pairs that he need to consider as well. So he only used one of them. So let's try to see other pair. So there are like 12 possibilities. He only showed one possibility here. So let's try another possibility. Let's say we consider 1 and 28, for example, or 28 and 1. Let's say this one. So that means 3x plus 2y equals 28, and 2x minus 5y equals 1. Okay, so now to solve this, we need to make the same. Let's say we times this by 5 and we times this by 2. So this gives us, just to make the same coefficient of y, so 5 times 3 is 15x. Each of the term will be multiplied by 5 in the first equation. So 5 times 2 is 10y equals 28 times 5. So use calculator quickly. 28 times 5 is 140. And then 2 times 2 is 4x minus 2 times 5 is 10y equals 2. Now if we add them, this gives us 19x. 10y minus 10y will cancel. 142. Now 142 divided by 19 is a fraction. So this gives us x equals 142 over 19. You can work out the y coordinate as well, but it looks like they are not integers. That's what he was meant to prove. There are no positive integers x and y. Okay, let's consider another case. Let's say we consider 7 and 4. So we write 3x plus 2y equals 7, and then 2x minus 5y equals 4. Now let's try to make x the same this time. Let's keep the y the same. So we times this by 5, we times this by 2. So 5 times 3 is 15x plus 10y equals 35. And then 2 times 2 is 4x minus 10y equals 8. Now we add them. 15 plus 4, 19x. 8 plus 5, 13, 1, 3 plus 1, 4. So again, x comes out as 43 over 9. We can work out the y coordinate, but it's actually not needed. So again, so like that, he needs to check all of them, all the pairs. We don't need to, I think we don't need to show all of them, but there may be other pairs as well. There may be one pair that gives us integer, but it says there are no positive integers, so probably all of them won't give integers x and y. So I think that's the proof. Let's have a look at the mark scheme. So first part is k square is k minus 2 whole square plus 1. I think that's what we had, k minus 2 whole square plus 1. And then yeah, he needs to consider other pairs as well. Yeah, and none of the pairs will give us integers. All cases considered with correct values and rejected correct reasons given in each case, not integers, including statement hence proven. We didn't get any integer values of x.